Can you see my screen? Oh, I need to get the speaker. Just give me a second. Yeah. All right. Let's see. Okay. Can you guys hear me okay?
Yes. Yes, Kadir, your screen is. Yes,
perfect. Let's
yes.
next 45 minutes or so. Let's learn something new together. Okay. All right. So just a quick intro. What we are trying to do here is, just let me see if my video is on. All right. Okay. So what we are really trying to do is, amid many different organizations, profit organizations helping with skilling up people. This is the new initiative, which is a non-profit initiative as a part of continuous learning program to skill up 5G technology. We have been successfully completed, I think, almost 6 or 7 sessions. 5 or 6 more sessions are pending. There's a lot of interesting topic that we will learn together. Thanks to everyone who supports these activities. Logistics, yeah, that's a good one. Let me put this into the chat. All right, so if you wanted to extend your support, please do reach out to us in the first 2 email address. If you're interested in donating this nonprofit initiative, feel free to do that. There is an Eventbrite registration link for the future programs of the same, future sessions of the same program. If you wanted to join, please use that link. And if you're a little bit lazy going and registering every week, you can always directly join using the last link that is available in the 5th line in the chat. Okay, all possible options depending upon your interest. And one more thing that I wanted to share is, just a minute, we have also decided to do a new initiative. It's almost in the draft, but I'm very happy to kind of share with you all that the initiative that we are trying to do here, again, it's on continuous learning initiative, is called as a Decoding Tech.Zone, which the concept of this is it's a zone where you decode the full power of technology, right? So that's the thought process. So we're planning to do a conference in October 28th. Mostly the venue will be finalized this week or early next week. It's almost done. So the topic is going to be on the metaverse and 5G conference, 5G, right? So that's what we're going to do. It's going to be a 1 full day conference in Canada. Obviously, those who are attending remotely may not be able to join, but we'll figure out, depending upon the sponsorship and the funding that we have, we'll have to figure out if we are able to directly stream this conference through YouTube and Facebook and so on, right? So we'll keep you posted, but happy to announce that we're planning to do this, and some of the work on the volunteer side have been started. Looking forward to this activity, which will again prove a point of a nonprofit can do a lot of activities on the high-tech area to skill up and innovation up individuals and turn them into a workforce of future. Again, thank you for everyone's support, and continue to look for additional support from you guys. Now, with that, let's jump into the session for today. All right. So logistics, we are closed, and why we are here, we basically wanted to make sure that we skill up and innovation up on you guys on 2 areas. One is the expertise related to the 5G. and also understand not only the theory part of it or just one open source. We have chosen Magma as an open source, but also try to understand how the whole end-to-end system works. And the plan is to also show how the end-to-end system works for 4G and eventually on 5G in these sessions. I'm happy to do that in the future sessions as such. Now, this particular session is split into two sections, right? So one section is all about the domain knowledge. It's very important. See, the future workforce is all about not being expert in one area, right? The future workforce is all about understanding the breadth of things, how different things come together. And then depending upon your interest, you can always deep into which area of expertise that you wanted to excel. But what's important is it's not good enough to have depth of knowledge in the area where you want to excel without knowing the end-to-end big picture, right? You will realize that as you go up in the ladder, but the faster you realize that, the faster you understand the big picture and know how to connect the dots of different things, the better you will be. You will be able to see better future, better you will be able to represent yourself better for your company, for yourself, for your customers and many other things, right? So we kind of divided this particular session into two blocks. The first one is helping you guys to understand the domain perspective in multiple areas, so you get that end-to-end picture, and also the depth of knowledge of one open source, as well as end-to-end working of that open source for fixed wireless access and private networks, how all these different pieces comes together, right? So one is the domain piece, another one is the technical piece, and that's how we kind of divided this session. So I'm going to start with the domain side of it. We have already covered greater depth into understanding different wireline networks and also understanding different wireless networks, including the 5G. And then the third topic that we are going through right now is standard and open source. So we covered a little bit in our previous session. I'll try to complete that. And then the fourth session would be the adjacent technologies, and fifth one is the spectrum. So the adjacent technologies, what we will be talking about is, okay, what is a cloud technology? How does that come into the picture? What is an SDN technology? How does that come into the picture? Not getting into too much of details, but at least understand the basic fundamentals, so you are able to connect all these different things, right? What is NFV? How does that come into the picture? What is AR, VR? What is AI? How does that come into the picture? How can it help from the communications point of view? How is it related to 5G? And nowadays they are talking about metaverse, right? How metaverse is related to 5G? Why they are saying that 5G is key for the success of metaverse? So those kind of big picture of different adjacent technologies, how it is coming together is important to understand. That's what we will cover in the section 4. And then finally, the spectrum. You don't have to really know thoroughly about the spectrum. There are experts, but at least you need to know what are all the different types of frequencies that are allocated into different slots for different services that can be offered, is some minimum that you need to know. So we will cover that. So by end of this 12 1-hour session, we strongly believe that you will have an end-to-end picture. You would be able to address any interviews or any customers or any projects that you would do in your company in a more educated and smarter way. Okay, so let's jump directly into the third session. So today the topic is going to be standards. Little bit, whatever that we left out, maybe 1 or 2 slides on adjacent technologies. We'll start with a very basic one, that is cloud, right? In fact, in our previous sessions, we kind of a little bit covered about some of the technologies like transport, network slicing, but the adjacent technologies are a little bit, beyond that, right? Moving on, let's start with the standards. So just a recap, what we learned in our last session is there's number of in the past, there's number of different standard bodies. There was a separate standard bodies in America called ANSI and then ETSI in Europe. But then over the period of time, it got converged, and they started something called as a project. This 3GPP is a project where different standard bodies and companies, they all come together and start defining one single standards, bring all these different variants and start developing one single standards that everyone can adopt and develop. In telecommunications and communications industry, it is very important to have standards, because we're talking about taking a phone from one country to some other country, it still continues to work, right? So the interoperability is key, and we wanted to build a product that where such kind of things can happen. Then you need to have a standards to follow, so multiple different products can work together, right? So that's why the standards are there. And what we learned was, how did this whole 5G standard came into the picture? It started on 2015 with the spec 22.891, which defined 5 major areas. And then 22.261 started defining the service capabilities, from basic service capabilities to the advanced service capabilities, like vehicle to vehicle, vehicle to robot, what a V2X, right? And then from there they started defining multiple different standards for more specific areas, right? So this is very, very important to understand, very basic stuff. And if you wanted to, this is a very high level, but it's very easy to master, right? If you wanted to really understand in which are all the releases, right? What features are getting developed in the standards, there is something called as a work item for ongoing releases and the past release. As you see in this, it's very easy. Go to the 3GPP spec and click the work item. You can download it in the form of Excel, and also you can see it in the form of web. And that will allow you to understand what are all the different features that are studying, that the standard bodies are studying for that particular release, and what are all the features that are actually developing standards for that particular release, right? So it's very easy to understand. And also it's very easy to screen only those features that is of interest to you. For example, if you wanted to understand network slicing, right? Or if you wanted to understand URLLC, then you can always, when you go to this Excel sheet, you will find a tag, right? 5G URLLC, and you can just search, filter that. Then you will know what are all the different features that are getting that are studied and getting implemented in stage 1, stage 2, stage 3 standards for URLLC, right? So it's very easy, and that way, if any topic that you wanted to do, and you can actually go and search, and then you can go from the previous standard to the latest standard, all the features that they have implemented, and then you will become master. So this is what I was talking about, understanding the big picture, and then with that big picture, knowing where to actually go and look into the details. So this particular document really will help you. And in 3GPP, what happens is that there is standards are gets defined in stage 1, stage 2, stage 3, right? Stage 1 is just the requirement, stage 2 functional description, stage 3 the actual protocol description. So this is also something that you should know. But when you get into this, you will automatically know, right? That's default. When you look at some standard spec with 24, 36, and you will actually know these are all the series has stage 3 specs, which is actual protocol definition, procedures definition. Stage 2 just the use cases, requirements, and stage 1 just the use cases. You will know all those things as you start involving yourself and playing around in this. But I sincerely recommend every one of you to go and play around in this, because it's very important. This will make a whole lot of difference for you as an individual. Trust me, right? Instead of Googling it, this will make a whole lot of, it will make you much better. Okay. Then what I also would like to share is that outside of 3GPP, there are many different organizations that defines the implementation agreement, they call it as, right? Sometimes the base is the standards, but what these organizations do is they study the standards, they try to see what additional modification is required in that standard to address a particular area of interest, right? See, this ACIA is the Connected Industries, which focuses on Industry 4.0 manufacturing flow, right? OT domain. So what are all the additional things that are required? And most of the time the standard addresses it. If sometimes it does not address, if it does not address, they go back with the inputs to the standards, and standards continue to get evolved, right? So like that, there is an organization which focuses only on automobile, right? 5G for automobile. You can just Google it, you will find it, right? And this is one example that I wanted to say for the connected industries. So this is also something that we covered in our last session. So there's 3 things, right? One is connecting to the internet. One is your traditional IT domain, where you have all the IT applications like Word and everything is maintained. And then you have an OT domain where actual manufacturing happens. So in manufacturing floor, if you look at it, there's a number of things that used to be there in the manufacturing floor, right? From SCADA to PLC to PID, we talked about in our last session, management, MES systems, CAD/CAM. So now all these applications have to be communicating with each other, and also these applications has to get the data from sensors, actuators, and many other data that you collect from the actual manufacturing floor, right? So you need a solid, high quality, high performance, low latency network, so that you are able to cater to the multiple use cases in the manufacturing floor. So for that, 5G will play a very important role, because the previous technologies, whatever we had 3G, 4G, versus 5G. If you look at it, we have talked about it in multiple times. The 5G is not only designed for people to people, but people to machine and machine to machine. It has features like low latency, high throughput, and time synchronization, right? A lot of different things that are part of this 5G network that will allow you to do better job in the manufacturing floor when it comes to the OT domain. Okay. Now, we also talked about the special characteristics in OT domain, why 5G is very important, right? Because OT domain availability is multiple nines, right? The communication cycle has to be very less. Latency has to be very low. Packet size also is going to be too small. It's not like 64 kbps or 1500 kbps, right? Bytes or packet size when it comes to the OT domain. It's going to be small packet size, and accuracy has to be very, very important. There's going to be number of devices. Think about, as an example, right? These are all theoretical stuff, but think about an example. A robot is trying to place a headlight in a car, and if the communication is a little bit slow, then before even the frame is placed right, the headlight, it will try to go in place, which is not good thing, right? So I just wanted to kind of give that as a practical example for you guys to understand that a little better. Now, in the OT domain, there are multiple automation areas, but the message here I want to give is every automation areas that you have and every use case, whether it's a motion control of the robot or control to control activities or mobile robots and mobile control, right? Panels, whatever, right? That different use cases that you have within the different automation areas in the OT domain. If you map that to a 5G characteristics, URLLC, EMBB, and some features require URLLC more, some requires EMBB more, some requires capacity more, right? Number of devices connected more. Like if you go to the smart cities and things like that, there's going to be a lot of devices that will be connected together. So, or in some cases, the combination of these things will play a role for certain use cases. So it's very important to understand that. Why? Because 5G having all these different features and characteristics is the right one of the right technology, depending upon the use cases you might adopt and use it. Okay. Awesome. So now when it comes to the deployment, okay, so there's multiple ways the private networks can be deployed. Okay, and I have taken these pictures from a tip document. So it kind of defines 4 types of deployment, right? So if you look at, end of the day, these are a little bit details, but end of the day, I wanted to let you know that depending upon the use cases, you would choose one of these deployment, right? These deployment models doesn't drive your use cases, but actually your use cases drive which deployment model that you're going to choose. Okay, so in some cases, what you can do is you can have a completely private networks within your OT domain, completely managed by you. Everything is inside, right? You don't have to rely on any service providers network or anything. So it's called as like dedicated networks. So that is one type of networks. There are use cases that requires that type of network, right? But in some cases, what you can do is you can actually have the radio, shared, and the rest of them is all dedicated in your OT domain. In some cases, what you can have is you can have the radio and control plane shared and the user plane dedicated in your OT domain. In some cases, you can have everything given to the service provider to operate that for you through a network slicing, which is something that we have looked at in the past. But the message that I'm trying to give you here is depending upon the use cases, you can pick and choose how you wanted to deploy your network. That determines what type of deployment model that you would go for your particular use case. Okay, so in this, if you look at it here, the left one, right? So the one that you see here is completely a private network and service provider network. So here, what does it actually mean is service provider managed private network. So the service providers, it could be, anyone, right? AT&T or Bell or Reliance, they can manage the complete network for the OT domain or for the enterprise customer, right? So that is service provider managed private 5G. Then you have private 5G with RAN and control plane signaling. In this case, what happens is on the private networks, you can have radio and you can have you can have radio and you can have UPF. Here, you have an UPF here, you have radio here, and you have UE here. And if you see radio, there is like white and yellow, and UE is white and yellow, right? Sorry, white and blue and white and blue, right? So in this case, what you're basically trying to do is, this picture might be too small for you to view it, but what you're basically trying to do is you're trying to keep RAN and control plane signaling either within the private networks or in the provider networks, and you keep UPF dedicated for you, right? So that is one type of a deployment. Then there is a third type of deployment where you are having a RAN sharing, right? So you can share the RAN between both private network and public network. That's another type of deployment. And then neutral host is some third party basically providing you the complete dedicated network, say, right? So these are all some of the different ways of defining. If you look at in many other places, they also define it in a little different way. But the bottom line, again, I go back to this fundamental thing, right? Depending upon your use case, you can either decide to have radio, core network, both control plane, signaling plane, including the management entity, everything into OT, or you can keep some of them in OT and some of them outside of OT. And you can allow some service provider to provide few parts of it and you manage few parts. And in some case, you manage everything. So all these different types of combinations they can play around. And why we are able to do this today? Because the 5G network is defined as a disaggregated network, right? So you can pick and choose different components that you want, and you can put it in a different places that fit your use case. That's the key message that you need to understand. So now if you move on to the next step, so this is, again, I took it from the tip, right? If you look at the top one here, so these are the 4 scenarios that you actually saw in the previous one, right? So they are trying to compare this scenario, whatever that they have defined, and how the 3GPP is the comparison to the 3GPP definition and the ACIA definition, right? So the scenario 1, right, which they call it as service provider managed private 5G, right? SPM, managed private 5G network. In 3GPP, they call it as a service provider non-public network. In ACIA, they call it as a standalone non-public network, right? It's a dedicated network. So this is kind of a comparison. Sometimes what happens is when you look at how different people are defining, you might get confused, right? So it's better to kind of compare it. So the first one is basically nothing but a standalone non-public network, meaning standalone private network, right? A dedicated private network. And the second scenario that you saw in the previous one is a shared radio access network. So radio access is shared, right? And then the third scenario, if you see is radio access control, and radio access network and control plane is shared between both private and public network. And then the fourth scenario, if you see, it's standalone, everything is provided through the public network in the form of network slicing, right? So this is what are the 4 types of things that they have defined in comparison to all those 4 type of things versus 3GPP, how they define it, and ACIA, how they define it. And again, I told you, if you remember, the type of network that you would choose depends upon the use case that you are going to deploy, right? So standalone private local network, you can deploy it for the industries, which is a manufacturing industry, and who is going to own the radio? Enterprise owns the radio. I'm just giving this as an example. So that is scenario 1.4. Right, so these things, a little bit more detail. My intention is not to go through every line, but to kind of give you guys an understanding as to, depending upon the different use cases, you choose which scenario that you want to deploy. And again, in this right-hand side picture, if you see it in OCN, you have these 4 scenarios, right? And spectrum, RAN, core, applications, management and orchestration, charging and billing. These are all the things that makes up your end-to-end network. Some of it we have discussed. I told you spectrum is key. And who owns the spectrum? You need to understand for the scenario 1, right? And who owns the RAN? Who owns the core? Who owns the applications? All that SCADA and the different applications that I talked about. And automation means you need management and orchestration layer in NFV architecture, which you will be learning in subsequent sessions. And when you deploy this, you also need a system which is charging and billing, right? It's called as a BSS system. So in some cases, OSS system also you need that will be part of management and orchestration. Now, this particular table explains you for each scenario, right? Who owns what? Let's take an example. So for the scenario 1 private network, the spectrum can be owned by the enterprises like CBRS spectrum, licensed and unlicensed, right? Or it can be owned by MNO. Radio, it can be private or it can be owned by MNO, right? Core, it can be private or owned by MNO. Applications, private and owned by MNO. Management and orchestration, sometimes they prefer to be shared with others, whoever is providing, and it can be owned by MNO. Charging and billing, the same thing, shared, and it can be owned by MNO. So what does it actually mean, right? So you can have the scenario 1 deployed completely private with few items shared and by enterprise, or it can be completely privately deployed by MNOs, right? So that's what it means. So you will have access to this slide and you can also go and look at these documents. But the key message here is two things, right? There's a different, because of the nature of 5G's disaggregated architecture, you are able to, slice and dice to build your network depending upon your use cases is the message that you need to get out of this whole conversation, okay? Now let's jump into the open source aspect of it. I'll try to see if I can cover this quickly. So in the past, it used to be standard bodies and the different companies used to build the products based on the standard bodies, right? The barrier to entry, like I mentioned multiple times, for us to learn these technologies was possible only when we were working in these big companies. But now with the open sources, the barrier to entry is completely minimized. In some cases, there's no barrier to entry at all, right? So you can go and contribute in the open source and learn all these different technologies without being or without working in any companies to learn those technologies. That's the beauty of open source. And open means innovation. Anything that you do that is open brings innovation, multiple possibilities for you to succeed, right? So from that point of view, Linux Foundation, we all know, is one of the biggest open source community, having hundreds and thousands of different projects, right? And Magma, one of the project that we are learning in this session, is also part of Linux Foundation networking, right? And there's a lot of adoption in Magma was increasing, and before it was managed by Facebook, now called Meta. Now it is completely managed by Linux Foundation, and it's an opportunity for every one of you to go and contribute and learn, which was not possible earlier in olden days, right? So that's the key message. And the most important project that I like in Linux Foundation is called as Linux Foundation 5G Blueprint. So this is key, right? This is going to really help everyone understand, from individuals to the enterprises to the service providers, how different components of how different open source that are managed by the Linux Foundation can come together to build and provide solutions for end-to-end network, right? 5G network, whether it is a 5G open source based network, or whether it is a 5G public network, or whether it is a 5G private network. It doesn't matter, right? You can pick and choose different open sources depending upon your use cases. But this is another key thing. So one is you got to be mastered in standards. Another thing is you got to at least understand a breadth of knowledge about different open sources that can come together that can help you to deploy into a network. If you look at this particular picture here, right? So all the components are here. You have a devices, and you have the edge, smart edge, and also edge, smart edge stack, right? So basically it's an edge, right? User, close to user, you can have an edge, and close to the service provider network, you can have an edge. And there are different open sources that allows you to manage from the infrastructure point of view, whether it is a smart edge and whether it is a service provided edge. Then you have a radio network, right? This number of open sources, Open RAN that is available. Then you have a core network, Magma, and also you have number of other open sources like Open 5Gs and so on. Then, all these things on the core has to be managed by the infrastructure. So you have a number of things like Docker to DPDK to infrastructure management, OpenStack to SDN management and orchestration ONAP, right? So all these different open sources that are available that you can fill in the blanks of all these grayed out things and you can build an end-to-end network, right? So that's the key message. And it's very powerful. Right? In the past, this was simply not possible, and it is very powerful. And I would also recommend you to go and look at different open sources that are out there and where and how it fits. Right? This diagram actually explains that very clearly. And for you to know, where and how it fits, it's also important for you to know an end-to-end picture, which is something that we have already discussed in the previous session. It starts from the user devices, the edge closer to the user, edge at the service provider, and then you have a core network and you have a radio network. Then you have a cloud infrastructure that manages all these software components, from the hypervisor point of view and also from the transport point of view, infrastructure point of view, and also automation, orchestration, lifecycle management, and service assurance point of view. So that's pretty much what you see here as an architecture, and different open sources fits into this particular architecture. Right? And in the blueprint, obviously, it's a big box, right? But they are trying to go one step after another. But end goal is to ensure that they are using some open source for RAN, open source for core, and the infrastructure is supported for edge, as well as for the hypervisor and the high performance activities like DPDK and so on, which is NFVI. It's called as Network Function Virtualization Infrastructure. And then in order to manage that, you need have an infrastructure management entities. For the edge, they are using EdgeX Foundry, and Anakat and ONAP and openness are used for orchestration, lifecycle management, closed loop automation, network slicing, and also real-time RIC and non-real-time RIC of RAN. If you remember when we were learning RAN, I was talking about AI coming into the RAN and managing RAN automatically. Those are the components called RIC and non-RIC. Okay. So end of the day, the key message by end of the session I wanted to give you is standards and open sources will allow you to understand end-to-end picture, which was not possible before. And it's important that you understand that. And when you wanted to get into the depth of it, you can also go and look at some of the requirement documents that are developed by these different organizations, right? Like, for example, TIP, what you see here is they have defined a requirement document, what all a product has to comply if you wanted to deploy a particular use case. In this, it is a fixed wireless access use case. For those who do not know what is fixed wireless access, it is nothing but a network that you deploy for connecting an unconnected, as an example, in the remote area in Africa, or in remote area where there's so many remote areas are there, even in Canada and also in US, right, where people don't have a connection. So you can go and deploy a fixed network there so people can get connected. So that's what it's called as a fixed wireless access network. And in some cases, you can also deploy FWA in the urban area as well, in the digital divide, where in one area you have lots of throughput, and in another area you have quarter of the throughput. So you can deploy FWA to provide more throughput on that particular area. So that's what the fixed wireless access network is all about. And private network is deploying private networks for the enterprises in the OT domain and for multiple other use cases for the different domains, right? So now why I explain this is sometimes what happens is the organizations like TIP and many organizations, what they define is they define a requirement that is specific for that particular use case. What you see here is one such requirement defined for fixed wireless access by the TIP community. Now, if you comply to all these requirements, then you will, if you build a product and each of your product complies to all these requirements, then you will be able to put all these different products to build a network. That's what it is, right? Now, this is not something, they don't define this as a new standard, but actually they refer whatever is applicable for them from the 3GPP standard. And they say, hey, these are all the requirements. You as a vendor, if you have these requirements implemented, then you would be able to deploy the fixed wireless access network. And they also have certifications and many other activities that they do to ensure that all these different vendors who are building are compliant to this requirement, and they provide certificates to them. And so that when an operator wants to deploy, they know that if they buy from this particular vendor, this particular product, when I'm deploying FWA, it will work, right? So that's what it is. So I'll probably stop here. Thank you. I took a little bit more time for today, but I just thought that it's important I close on this standard bodies activity or session today. That gives a very little time for our technical team for the second session. Without further ado, I'd like to hand over the session to Yokesh. Just remember this one point. It's very important for you to understand a big picture from the standards point of view, as well as from the open source point of view. If you wanted to personally succeed, professionally succeed in the company that you work for, and also kind of appreciated by your knowledge base from the customer point of view. So with that, I'll hand over it to Yokesh. Yokesh, see if you cannot finish a lot, but at least you can show a trailer kind of a thing now and maybe cover the details in the next session.
Sure, Kader. So thanks very much, Kader. I think definitely the way you pointed out how the open sources are filling the shoes of the big enterprises, I think it's worth learning those. So we don't know we will be able to cover, but at least we'll go through the slide. And if the time permits, we'll go for the demo. Otherwise, maybe we'll post the demo for the next session. Yeah. With that, just give me a second. So I will just cover what we have done till now. So I think it's just a quick recap in case if somebody has not attended the previous sessions. So what we have seen was in Magma, we have AMF, SMF, UPF, and we have a UE GNB. So when UE is going to make a call, it is going to attach to the GNB, and the GNB will get the UE registered with AMF. And then, once registration is successful, UE is allowed to access the internet. Of course, first step will be to create a PDU session. And with that, the resources will be dedicated, and then we will reach the internet. So this is like, once registration is done, how the stack looks like. Basically, this is the UE, GNB, UPF, and DN. So between GNB and UPF, there is a tunnel. And this diagram shows what are the different components of the stack involved in the fast path. So I think this we have covered the installation, the open source we are using, the open source GNB UE platform. Today, what we are going to do is we are going to have an overview of the orchestration component. Till now, we have just showed we were having pre-configured variables like subscribers were pre-configured, and a lot of things were pre-configured to simplify the overall flow. But what we wanted to show now is how actually we can configure it from a NMS dashboard. Yeah. So Lavanya, over to you. Shall I keep on sharing the screen, Lavanya?
No, I will share the screen.
Okay.
So hello everyone. Just share my screen. Is the screen visible to everyone? The screen is visible, right?
Yeah, it's coming up, Lavanya. At least for me, it's coming up.
Yeah,
So
I think
Lavanya
it's right now.
Okay.
It's a black screen.
Okay. So Yogesh, can you share the screen? I think
sure. Absolutely. I'll share my screen. Sorry for the hiccup. I think this happens.
Yes. So yeah, today's agenda. I'll start with today's. So we'll be talking about orchestrator and NMS. So yeah, the today's agenda. So I'll start with a brief overview about orchestrator and what are the different components of orchestrator, what are the different interfaces they're involved. Then I'll move over to orchestrator and NMS installation part. Although we'll not cover this in this presentation, but I'll give a hint at what is the proper resource to look at if you are interested in setting it up yourself. Then I'll cover the Swagger API that is a part of orchestrator and that is required for complex configurations. And then I'll move over to health check part through which we can validate whether the connection between the orchestrator and our AGW is correct or not. If not correct, then how to resolve it. Then I'll also touch upon the organizations part and how there are different organizations and different organizations can be like managed through this organizations window. Then I'll introduce the NMS dashboard. What are the different components of the dashboard? And then I'll touch upon all the relevant dashboard components like adding subscriber, policy adding, and Grafana dashboard mainly. Then after that, I'll end the session with a demo video and I'll explain all this thing, whatever covered in the presentation. I'll demonstrate it in that video. So yeah, next slide. So yeah, the brief overview of orchestrator. So orchestrator is the centralized controller for the networks. It can handle the control plane for different gateways, like not just one, but multiple gateways can be attached to the orchestrator, and inside that we can also manage that multiple networks there. So it basically have two APIs, one northbound API and one southbound interface. So the northbound API, REST API exposes the configuration and matrix for the network device. That is, it sends that AGW's configuration and sends the data from AGW to orchestrator in the northbound interface, and the southbound interface applies the configuration and reports the device status. So right hand side we can see the very brief like architectural overview of the orchestrator application and how it is connected with the Magma AGW and different other different components like SQL database and Kubernetes and all that different how it is connected to that. So, next slide. So yeah, the quick installation part. So we have different flavors and different ways to install the orchestrator. Yeah. We have different flavors and different ways to install the orchestrator. We can install it on bare metal, we can install it on cloud, we can install it in a container environment in Kubernetes, and we can also install it in the laptop, our local laptop setup. So right now the demo which I will be presenting that has been recorded on my local laptop setup. So if you want to install it over the local laptop setup, you can follow the second point link, that is the quick installation link. And for other deployment or installation steps, that would be covered in the subsequent presentations and subsequent sessions that will be covered. So next slide. Yeah, Swagger API. So this is the Swagger API. It is a part of orchestrator through which we can send complex or complicated this configurations, or we can fetch the configurations. Basically, it can do everything that can be done through NMS and more of that. So if you are expert and you are looking to debug some problem, or if you are looking to test out some complicated settings, or for that we can definitely use the Swagger API. So I'll be covering this in a video also, but we can post, get request, post request, delete, get, put, everything. Every REST API request can be put from this Swagger API, and it can be put for our different components also. So in the home, the left hand side, we can see that there are LTE, CWF, carrier Wi-Fi, and Event Federation Gateway. All the components are supported here. So we can do different kind of testing through this Swagger API. Next slide. So health check. So once our orchestrator is up and our AGW is also up, but if we need to validate that whether they are connected properly or not, so in the AGW side, we can run this command health check CLI.py, and it will give us a summary whether the orchestrator and AGW's connection is good or not, or if it is not good, then it will also suggest the steps which can be used to troubleshoot the issue. So if it is good, it will show success, and if the connection is not proper or there's a bad health of the connection, it will give you it will give you some pointers like how to debug that. Yeah, next slide. So yeah, NMS dashboard. So this is the default view of the NMS dashboard when you have like when you will open it for the first time, when you are when you have brought up the NMS and you are opening it for the first time, you are logging in. This is how it will look because there are no networks added here right now. So we can add the networks to NMS dashboard through two ways. The first way is we can see in the top right corner add network. This button is there. If we click on that, so we will be able to add the network. So it will ask us, it will open a dialog box. It will ask us for different configurations and all that. But there's a second way that your network is already added in your host organization, and now this is your second organization or an alternate organization, and you want to add a network to that, add the same network to here, or you want to access the network through here. So you can enable it through a different place, and I'll in the next slide I'll be discussing how you can do that. So next slide. Yeah, so organizations. So NMS also give us the access, so we can create multiple organizations depending upon what are the different requirements or our business requirements. We can make different organizations. Like for example, in here there's a default host organization. There's then FB test organization which is there, and Magma test organization, which are these three organizations by default comes into picture if you install it through quick installation guide. So right now, if you can see in point number 3, Magma test, there are two networks that are accessible, MPK test and test. So in the video, I'll be showing you how did I enable this test network and how you can enable and disable different networks here. So yeah, next slide. So yeah, this is the view of NMS dashboard. Once the test network has been added to it, or once it has been enabled inside that organization window, once we enabled it for our present organization, this is how it looks. So left hand side we can see multiple small buttons are there. So the first one is the equipment button. Equipment section opens the equipment section. Second one will open that network sections. Yeah, I mean the third one from top. Yeah. Then the subscriber. We can, if we click on the fourth one, the subscriber section would be open. Then policies, and after that call tracking and other different matrices and configurations can be opened up. So I'll be covering in this presentation. I'll be covering in adding subscriber, that is subscriber section, then policy section, and the metric section. So next slide. Yeah, thank you. So adding a subscriber. So once you click on that subscriber button and then you click on the add subscriber window, this window will open up. And here we can see there are multiple there are multiple columns. That is IMSI, subscriber name, auth key, auth OPC, service, and other different parameters are there. So there are two ways to add a subscriber inside Orchestrator or NMS dashboard. One is that we click on the add new row button, then we can add one subscriber at a time. So once we click on that add new row button, we will be able to type this this field values. We will be able to enter the values into that, and then we will have to click on add subscriber at the top left corner, top right, bottom right corner. Yeah, that one. So yeah, so as we all know, IMSI is this important parameter to identify a subscriber. So you'll have to add that IMSI value, then the name of that subscriber, and auth key, auth OPC, service value we have to put it as active, and then forbidden network types are has to be put in if we want that subscriber to limit to a particular network, like a particular technology basically, whether we want the subscriber to just access 5G, or if we want that subscriber to just access 4G, then we put a value here. Otherwise we can leave that blank. And then data plan, what is the data plan for that subscriber, what is the amount specified for that subscriber to be used, and then APN values. and active policy. So 5 fields are very necessary to be filled. Other fields can be left empty. That is IMSI, subscriber name, auth key, auth OPC, and APNs. So these fields have to be filled anyhow if you want to add a subscriber. And yeah, next slide. So this is the view of the CSV file which you can upload to add multiple subscribers at the same time, as I discussed in the previous slide. If you click on add CSV button and then upload a file similar to this. So this CSV file has to be written in a very particular format, that your this first column need to have that subscriber IMSI value. Second column need to have this IMSI name, that subscriber name, then auth key followed by auth OPC, and then status of that subscriber, that is active. Then after that, like whatever way the dialog box were there, that similar way you have to fill it there. And if you want to leave anything blank, you can leave anything blank, but you have to start from the A1 this box. A1 cell, you have to start from the first cell itself. Otherwise, it might cause an error while parsing this CSV file. So yeah, next column, next yeah, slide. Thank you. So yeah, once that subscribers has been added from the NMS, there's a way to validate whether the subscriber are there in our subscriber DB or not. So in the AGW CLI, we run this command subscriber CLI.py list, and it will show you all the subscribers that are there in our AGW subscriber DB. And if you want, you can also view the details of that subscriber using another command, that is subscriber get, and that space name of the MC or name of the subscriber, and you will be able to view that subscriber's property. So subscriber get space this MC value. Yeah, next slide. So policies. This dialog box appears when you want to change or modify a policy. So right now we can see that there are 3 policies added: policy 1, policy 2, and metering rule. And in the video, I'll demonstrate how to add a policy. So what is policy exactly? So policies are the parameters which actually specifies the quality of service to the subscriber. We can add different rules in the policies, like different flow rules. We can add a flow table. We can also modify that existing flow table. We can limit the subscriber. If they are trying to access a particular IP, we can block some IP. So all these things can be added or modified in this policy section. And I'll also demonstrate in the video how to add the policy. Yeah, next slide. So policy validation. Once the policies are added, we can validate whether they have been forwarded to the policy DB or not. So in the again in the AGW CLI, we put the following command: policy DB CLI by dump data, and it will dump all the policies which have been added, and it will also show like whether which subscriber has which policy enforced. So for example, right now when I added the subscriber, I did not enforce any policy to any subscriber. So that is why we can see after colon it is empty, there's nothing there. But if we enforce any policy, or if we enforce multiple policies, all of that would be there in this when we run this command. The output of this command will show everything. So yeah, next slide. So finally, yeah, Grafana dashboard. So this dashboard contains the so through this dashboard we can see all the matrices of our network. That is, we can see the subscriber side data, and we can also see the AGW's machine data. That is, what is the RAM being used, what is the number of cores being used, what was the CPU usage, and all that we can see in the Grafana, and that too in a presentable way. That is, we'll be able to see the graphs, and we can go through all the different subscriber and all that. So yeah, next slide. So yeah, now I'll be presenting the demo video. So before that, I'll explain what is the topology that of my setup that I am following. So there are two. There's one VM that is in which my Magma AGW is installed, And then in the laptop itself, I'm running some Docker containers, which contains the orchestrator and NMS dashboard installation or instances. So yeah, this is a pretty simple installation setup. If you also want to test out it in local setup, you can use that link which I showed a few slides ago. So yeah, Yogesh, do you have access to that video?
Yeah, Kader, we are almost to the end of the session. That video will take around 7 to 10 minutes.
Yeah, I think let's do it. We have to respect the time.
Sure.
So let's do it next week with a quick recap of this, and next week I'll give more time for you guys and talk less on the theory side, so that we can cover more grounds.
Sure,
Yeah.
sure, Kader.
Yes.
And
Thank you.
Avanya, I'm very impressed with your presentation. Great job, right? And I want every one of the volunteer here to come up and take this platform as a base to learn more and become successful. Good work, good work.
Thanks a lot. That means a lot coming from you. Thank you.
Perfect. So thank you guys. You all have a wonderful Saturday evening, Saturday afternoon, morning. I'll see you guys in 2 weeks. Take care. Bye-bye.
Thank you.
Thank you, Kader. Thank you.
Thanks everyone. Bye-bye.
Thank you, Kader.
Thank you.
Thank you all.